So this is textbook. We're going to have this item that we call the unit circle. I'm going to call this the unit circle. Now, as a definition, unit circle is a circle centered at the origin. So there's our center right there. Centered at the origin. Now unit circle, units meaning 1. The radius is going to be 1. So unit circle is a circle centered at the origin with radius 1. So center of the origin, our radius is 1. Good? What we want to think about is it's going to be all properties of this specific circle. Everything's going to come down to the circle. Back at the beginning, we started talking rotations. Well, with rotations, we have circles. If we keep on rotating and rotating, we have circles. Forget about triangles. Triangles were worthless. We never want to seek another triangle again. Back to Algebra 2. Do we remember circles, conic sections? Do we remember the equation of a circle? Those of us that saw conic sections last year. Okay. Not really.
Never heard of this word.
Circle? Or equation. Conic section? Unfortunately, it's not something we're going to talk about. If you take a cone and you take a plane and intersect a cone, you get different shapes. Circle is one of them. Equation of a circle from conic sections. Anybody? The general equation, x minus h squared plus y minus k squared equals r squared. And let's think about this. We should be able to understand what this is saying right now. We should understand this. This x minus h squared. What do we think that minus h does to the equation? What is this minus h, excuse me, the minus h in the equation, how does that change our graph? Was it?
What's h?
It's going to be a shift. That's a shift. Which direction is that shift? X. This is a left or right shift. This k, how is that k going to change our circle in a graph? That's going to move us up or down. R is actually going to be our radius. R is our radius. Right. Thanks. So, in terms of our unit circle, our center is right at the origin. So we have x squared plus 0 plus y squared minus 0 equals 1 squared. So this is the equation of our unit circle. This is the equation of our unit circle. Now what we want to do with our unit circle is the equation gives us every single coordinate around the circle. The equation gives us every single coordinate going around the circle. We want to be able to find coordinates around a circle. So we'll start off, we're centered to the origin, our radius is 1. Let's see if we can think our way through things. If our radius extends straight to the right, what's the coordinate where the radius hits right on the x-axis? Where is that point where the circle hits the x-axis? What's that coordinate?
Oh, the radius.
It's 1, 0.
That will be 1, 0. 1, 0 is the coordinate because the radius extends 1 unit to the right, 0 units up or down. We can find an exact coordinate somewhere on a circle. If we go north, if we go straight up, what's the coordinates
0, 1.
at 90 degrees is going to be 0, 1. What's the coordinate to the west, straight to the left?
0, 1. No.
That was 0, 1.
Negative 1, 0.
That one is negative 1, 0. Can't be the same because it's in a different location. Straight down. 0, -1. Those are the coordinates for our quadrantal angles. Going back to a previous definition, those are the coordinates for our quadrantal angles. Quadrantal angles. Those are all of the axes. Those coincident with the axes, meaning they are the axes. That would be 90 degrees, or we can include 0 degrees, 90, 180, 270, blah, 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 blah. Keep on going. The question then that we have how can we find the other coordinates around the circle? How can we find the other coordinates around the circle? Pythagorean theorem only works in what kind of figures?
Triangles, so let's make some triangles.
That's a good idea.
In the circle.
Make some triangles in the circle.
Well, no, because there's like,
So if we take
an arc equation thing, right?
arc length, portion of the circumference.
Let's go
Joan of Arc.
Joan of Arc has nothing to do with this. How do we find those other coordinates? So if we just pick some arbitrary coordinate there, how do we find that?
If we just pick a random coordinate.
And we pick a random coordinate. We have an angle that intersects, goes up through that coordinate.
You drop an altitude.
Ah. So let's take a look at this.
Is that correct?
Does that make sense? How is that going to help? All right, I'm going to get rid of the rest. Let's pick a nice angle. What's a nice angle that we know?
90.
Different one.
45.
45 degrees. What is the coordinate at 45 degrees? Oops, can't see any. There we go. What's the coordinate at 45 degrees?
Oh, it's
Could just be so many things.
Here's what I'm looking at.
He's at rough day gym today. Drain jump.
is it 1/2?
1/2, 1/2.
Is that right?
Let's see why that makes sense. Let's see why that makes sense. 0 degrees. 0 degrees, we had 1 0. 90 degrees, we had 0 1. 180 degrees, we had -1 0. 270 degrees. Now let's look for the pattern. We have 0 1. 360 degrees. We had that's -1. Sorry. Back to 1 0. And then we kept on repeating. We can go to 450 degrees if we go around, and then a little bit more, 450 degrees. I'm looking at, we'll focus on one value at a time. If we look at just the x values, well, the pattern goes 1 0 -1 0 1 0 -1 0. Do we know of any kind of like rule, any kind of function that has this kind of pattern?
Binary code.
Oh, binary doesn't go negative. Binary is more a number system rather than a function. Is there anything that we know that just 1 0 -1 0 1 0 -1 0? So we're wondering 45 right in there. The y values, just to kind of see those written out. The y values 0 1 0 -1 0 1 0 -1. The y values have the same pattern. But we wanted 45 degrees. I'm going to draw this in there. (45°). And we want to know that coordinate. Now, Jackson suggested 1/2, 1/2. Yeah, we like that? Well, let's go back to, if it is 1/2, 1/2, it's got to work in our equation. So we should have x squared plus y squared equals 1. If we plug in 1/2, 1/2, we get 1/2 squared plus 1/2 squared
Oh no.
equals 1. What's 1/2 squared?
1/4.
That's 1/4 plus 1/4 equals, well, 1/2 does not equal 1. So it's not 1/2, 1/2. It's not that nice linear relationship. Shoot, that does not work.
Jackson, I was still.
It was a good suggestion based upon the information that we had. Anything else we can do to find that? Oh. 45 degrees. We've seen 45 degrees before.
I feel like we should use the.
Can we use triangles? Do we have a triangle here?
You put another leg in.
Ah, if we put another leg in. So going back to the idea that was suggested, hopefully somebody else heard it. If we drop down in altitude, we turn this into a triangle. We create a triangle inside the circle. Now with this, does that help us? How can we use that to find the coordinate there? SOHCAHTOA, we've got a right triangle. How long is our radius? Our hypotenuse, our radius is 1. Well, the x value, thinking about geometry.
That's what I said.
Yes, that's what you said, so stick with me still. The x value is this distance across the bottom. If the hypotenuse is 1, what's that distance across the bottom? We'd have to use the Pythagorean theorem for that. Well, we know 45, 45, 90 triangles. What's the relationship between sides of a 45, 45, 90 triangle? Those are equal. That's x. That's x. How long is the hypotenuse? It's x root 2. If we've got x, x, x root 2, I need you guys with me still. We've got x, x, x root 2. Well, if x root 2 is 1, oops, let me write that. X root 2 equals 1, right there. Well, then x would be 1 over root 2, which when we simplify is root 2 over 2. So that x value is root 2 over, that's a thing. That's, oh, but which thing is it? We've got 45 degrees, we've got root 2 over 2, we've got root 2 over 2, we've got two different root 2 over 2's. It wouldn't be 1, because that's x is you going over, the y is going up. In a 45, 45, 90 triangle, what do we know about the two legs?
They're equal.
Those two have to be equal. So x is that root 2 over 2. Y is also that root 2 over 2. So we've got root 2 over 2, root 2 over 2. We've got a coordinate on there.
Go back to that small sheet, the other small sheet. Okay, there we go. Yeah, I didn't-
Here, x and y are the same. But we're right pointing out that that's a thing. That's a thing. Look at that right there. That's a thing. But what specifically is that thing? Let's take another angle that we know. 30 degrees, 60 degrees, 60 degrees. Let's take this. Just to keep things simple, I'm going to only draw in the first quadrant. If we go 60 degrees, we're somewhere up there. we want to know what is that coordinate. What is that coordinate for 60 degrees? Well, once again, our radius, the radius is 1. Do we see any triangles?
Yeah, drop the X.
If we drop the altitude, that's 60 degrees. Our x is that horizontal distance, and it's always going to be to the x-axis. Our angle is always from the x-axis rotated up. It's always to the x-axis. Don't forget, it's always to the x-axis. Hypotenuse is 1. There's 30 degrees. What segment is shorter? Which segment is shorter, the x distance or the y distance? Which one is shorter? The x distance. How do we know the x is shorter?
See it.
Don't trust my drawing.
Pythagorean theorem.
Don't, oh, we haven't used the Pythagorean theorem.
Yeah.
This is opposite the smallest angle, so this side has to be shorter. This has to be longer. So this was the x. Now if we remember back to our 30, 60, 90, look how nice I drew that. That was x. That's 2x. That's x root 2. I lied. X root 3. Sorry. So if 2x is worth 1, x would be 1/2. That's 1/2. What's the y value? 1/2 root 3, or we're going to say it root 3 over 2. Root 3 over 2. From that. That's a thing. 60 degrees. 60 degrees. So Jess is saying that x is cosine of that angle, y is sine of the angle. Well, that at least worked for these two. Notice, 60 degrees, cosine. 60 degrees, sine. Going back to the 45 degrees, x. Cosine. Y. Sine. Now can we take away the numbers and do that for certain for everything? Let's just verify this. If we take this away and go into just the circle, we take away all those numbers like the angle measures. For some angle, now by definition, we have a radius of 1. Our coordinate is always xy. X is the distance over, y is the distance vertically. So this is x from here to here. This is y from there down to there. Well, relative to the angle measure, where is the x located? That's adjacent. We've got adjacent, we've got hypotenuse. Adjacent hypotenuse. Cosine of the angle is adjacent over hypotenuse, is x over 1, which is just x. Sine of an angle. Sine, there's our opposite side. It's always the y. Sine is y over 1. It's always just y. So we have for any coordinate around the circle, that xy coordinate is always cosine sine. The x value is always cosine, the y value is always sine. Any angle around the circle. Or at least quadrant 1. Does the same thing work in quadrant 2, 3, and 4? We're quadrant 2, 3, and 4 because we are beyond 90 degrees. Now if we think back, how much time do we have? If we think back, on Friday, I'll put it back. Cosine of 90 said 0. Well, if we go to the circle, 90 degrees, cosine was 0. Based upon this, it makes sense.